解锁，请取出话筒。
Hello, testing. Okay, while waiting for the rest to come, we can try some exercise first. But before that, let's recall what we did on Wednesday. Okay, on Wednesdays, we introduce what is called the double integral or multiple integral, but multiple for us only up to two variable for now. Okay. The last thing we'll learn in this course is up to triple integral. That's the last thing. But now we'll do double integral first. So what's the property of double integral? So by definition, it is a doubly limit of doubly sum. Okay, but we won't use that definition to compute. So what have we learned? What's the tool we have learned last time? As long as your function is non-negative, okay, what's the doubly integral computing? What's the double integral computing? It is just the volume under the surface. Okay. So if your function of two variable is always non-negative, then what's this doubly integral computing? It is just the volume under the surface of fx. Okay. And above the domain. So in this case here, what's the integral domain here? It is R. Okay. So, well, I mean, whenever we talk about a function of two variables, you should think of it as a surface. Okay, you should think of it as a surface. So you should attach every point in R to a height, okay, for fx. So this is a graph of fx. Right. So how about the other way? So the other way is what called the Fubini's theorem here. So Fubini's theorem is kind of powerful. So how powerful is it? So if your function is continuous on a rectangle, okay, on a rectangle, then how do you do the double integral? Okay, so it doesn't matter you take what order to integrate. So what do I mean by what order here? So you can write this double integral as a iterated integral. Okay, so you can choose to integrate on x first and then try to integrate on y. Or you can do it on y first and then do it on x. Okay. Yeah. So basically, you split the double integral into two partial integration. Yeah. Okay. So this only worked for rectangle, but the last part we stopped was on a general region. Okay, on the general region. So we can change it to general region instead. Okay, more generally. So more generally, we can do iterated integral on non-rectangular domain. Rectangular domain. Okay. More generally, we can do it on a non-rectangular domain. So let's look at this example. Let's try to integrate x plus 2y. So x plus 2y is a function of two variables here. Okay, so it defines a surface in R3. So where's your integration domain here? So this integration domain is bounded by two curves. Okay, so what's the two curve here? One is y equals to 2x squared, and then the other is y equals to 1 plus x squared. Okay, so if you try and plot these two curve out, it will bound a region like this. Okay, the shaded region like this. Okay. So you notice that there are two intersections, okay, between these two curves here. Do you know how to find the intersection or not? Find it. You know how to find the intersection? Okay, so you equate the two equations here. Why you can let them equal? Because by definition, if you want to find the intersection point, the intersection point must lie on the both curve. Okay, so they must satisfy the two curve equation together. Okay, so you can equate them together. Okay. So I mean, so you can write that the intersection of the two parabolas will satisfy x squared equals to 1 plus x squared. Okay, and then you imply that x is either plus or minus 1. Okay, and then you put it back. Put either one back, right? Because it will satisfy both. So it will implies that y is either 2, it's just 2. Okay. Okay, so you found this um, two intersection points here. Right. So I mean, how should we integrate over this D region here? Okay. So by theory, right? So how do we integrate over this general region? So we imagine that this general region sit inside a square or a rectangle. Okay, so we can use iterated integral also. Okay, so we also can use iterated integral also. So if we're gonna use the iterated integral, you need to decide the order. Okay, so do you want to choose dx over dy or dy over dx? Okay, we should do both, and then to let you see which one is easier. Okay, to do. Okay, so what's your choice? Do you want to pick dy dx or dx dy? dy dx. Okay, so let's try dy dx first. So let's try dy dx. Okay, so so we need to decide our integration domain here, x and y. So although our integration is due from inside to outside, you need to fix in this case, you need to fix your x with a constant first to make sure that what you compute here is left with a number. Okay, if you have a function left with the outermost integration, right, then you will come up with possibly a non-number answer, right? Okay. So since we do dy first, we need to fix our x domain first. So from this picture here, where does this x range from? -1 to 1. Good. Okay, so -1 to 1. So in this case here, how do we decide y? So if you look at a single x here, okay, let's say -1. What is the y here? Y only have one point. Okay, y only have 1 point. From where to where? For x equals to -1. Y is going from, is bounded above and below by 2. Okay, it's just 1 point. But you can see when x changes, okay, the y interval also change. Okay. In particular, when x equals to 0, what happened to y? Y is going from where to where? Y is going from 0 to 1. Okay, so how to get this one? You just substitute 0 into the upper curve here. And then you can see that when the x move closer to 1, the interval y get decreased also. So how do you describe all these intervals? How do you describe all these intervals? Huh? How do you describe all these intervals? Do you have a way to describe all these, the changes of these intervals here? Can you make your y depend on x? Huh? Uh-huh. What's about 1 plus x squared then? Yeah, function. How do you use that? How do you use that? 1 plus x squared. Right. So 1 plus x squared is the upper bound for y, and then the lower bound for y is what? It's just 2x squared. So once you write this down, right, you can check. Okay, you can check whether it give the right y interval for you or not. In particular, for example, you put -1 into this bound. Do you just get 2? You just get 2. Right, so 2 times -1 square, right? So you get 2 for the lower bound. On the other side, you get 1 plus -1 square. You also get 2. Okay, so these two functions indeed compute the possible interval for different x's. Okay, okay, okay. So we determine our integration domain here. So let's put on y, we integrate from 2x squared to 1 plus x squared, and then x from -1 to 1. Okay. So after you write this down, right, you still can check whether this multiple integral makes sense or not. Does it make sense? Okay, when you integrate over y, you are substituting x function. And then whatever left here is in terms of x. And then you integrate with respect to s. Okay, so you can get rid of all the x in here. And then compute a number. Okay. You want to try and compute this? And tell me what's the answer. Try and compute this. 誒，小朋呢？ Hmm? Do you get something? You get $30.50. $30.15. You get $32.15. Okay. Okay, so for those who have done, you can try the other direction. What's the integration domain for the other direction? It's around getting 34, 32 over 15. Okay. Okay. If you stuck, you can try and ask, stop me. Okay, how about if we're trying to do dx over dy? So to do dx over dy, what do? You need to fix the domain for the outermost variable first. And then you fix for x. Okay, x will depend on y. Okay, in this case here, you see from this picture here, y ranges from where to where? What's the highest point for y? Y equals to 2. What's the lowest point for y? 0. Okay, good. Okay, so how does x changes in different y here? Okay, so if you look at the top y, it is also still 1 point. But not just 1 point right there, actually 2 point there. Okay, so at y equals to 2, it should give you 2 points. And then when y decreases, you can see that the 2 point will kind of expand. Okay, kind of expand on both sides. Okay, kind of expand on both sides until you reach y equals to 1. When it is y equals to 1, it forms a line here. Okay, and form an interval. Okay, so the two interval, the separated interval kind of join together. And then the interval kind of decrease until it reach 1 point here. Kind of difficult. How to describe this? How to describe this? So at the start, you have a separate interval, and then until the middle, you have a combined interval, and then finally you get the point. How to describe this kind of interval? Any idea? Okay, so we can kind of split it into two cases, right? I mean, literally is three cases actually. So there's one interval here, the other interval here, and then the last interval here. Okay, maybe we can split like this first. Okay, so what do I mean by this? So let's split y from from where to where? 0 to 2, 0 to 1, and then also y from 1 to 0. Okay, so let's split like this first. So, uh, so if you do it from 0 to 1, uh, sorry. Oh, sorry. Okay, thank you. So when you look at y from 0 to 1, what is the left bound and the right bound? What's the left bound and the right bound here? What's the bound for this side of curve? Minus square root y over 2. Let me think. Yeah, y over 2. Okay. You know how to get this? So, well, I mean, this outer curve here is described by y equals to 2x squared. Okay, but if you want to write x in terms of y, you should split your y equals to 2x squared into two parts here. Okay, so on the right hand side, you should describe it as square root of y over 2. So there are two parts here. Should I draw it like this? So here got one part, and here got the other part. Okay, so on the left hand side is bounded by negative square root of y over 2, and then on the other side is square root of y over 2. So this is a bit like the upper semicircle and lower semicircle, right? That we did last time. Okay. How about y in between 1 and 2? So there are two possibilities, right? So there are two possibilities. So you should describe the left one also and the right one also. Okay, so how to describe this? Do you know how to describe this part of curve here? So, okay, so let's remove this line. So you should work it out from the curve equation itself. Okay, so how do you write x in terms of y? You can write it as x equals to y minus 1 plus minus 1 square root. Okay, plus minus 1. So plus minus 1, which one work for plus, which one work for minus? Which part of the curve? Plus which part of the curve? Left side is what? Left side is minus or plus? Minus, right? X equals to minus square root y minus 1. Plus is on the right side. How do you see? How do you decide minus or plus? You can see that on the left hand side, x is less than 0. Okay, so you should use minus square root y minus 1. Because square root is always positive. Okay, so you need to multiply a negative to get a left hand side of your. Okay, so you can see that both above and below, you use the negative square root. Because square root always compute to positive. And the square root function is like this on the positive side of 1. Okay, so for y from 1 to 2, we have two s's. So s will be ranging from square root y over 2 to square root minus square root y minus 1. The other x ranging from square root 1 minus 1 to square root 1 over 2. Okay. Yeah. So in this case, if you do dx dy, you need to compute how many integrated integral? 3. Okay, so you need to do 3. Try and do it. Okay, prove to yourself that they computed the same thing. Okay, try and do it also. Again, they should compute the same thing. Okay. Well, I mean, the multiple integral technique here is really how to split your integration domain. The integration, what you did is what you learn in calculus. Because what we really do is partial integration. So you really integrate over one variable only. Okay, but the point is how you split the domain up. Okay, and then maybe one order is easier than the other order. Okay, so you should experiment it out. Okay. Any question? Feel free to ask. If you stuck, it's okay because this is in the process of it. Any question? Okay, it's kind of important how to decide this bound here. Okay, how to move from function in x into function in y. Yeah. Okay, so let's try one more question here. So, well, I mean, so since you're MAT, right? This diagram, right, we won't provide you. Okay, you should draw it out. I give you function curve, you should draw this diagram out. So let's try on this question here. Let's not look at the diagram first. Try and figure out the integration domain yourself. So try and find this volume under parabola above the region here. So how to draw y equals to 2x and the parabola y equals to x squared. Okay, and then look at this region. Okay, so try work out the integration domain only. No need to compute the integral. Let's check we have the same integration domain or not. So I give you 2 minutes, try and draw the integration domain out, and then decide what's the integration domain that you need. For any order you pick. Okay, either you want to do dy dx or you want to do dx dy. Okay, so did all of you get this graph here? Okay, so first you can get the intersection point is 0, 0, and 2, 4. But how do you know which one is higher? How do you know y equals to 2x is above y equals to x squared? How do you check? In principle, how do you check? Sorry? So you try some values, right? Okay, so you just try some values y equals to uh x in between 0 and 2. Okay, so for example, if you check 1, x equals to 1, you can see that 2x will give you a larger number than x. So you can see that only on this region, y equals to 2x is higher than y equals to x squared. Above x equals to 2, x squared should be larger than 2x. Okay. Okay, only within this region here, now x squared is higher than 2x. Okay. Right. So what sort of order you pick? Okay, let's pick someone. Isaac. Which order you try? dy dx. Okay. So for dy dx, what do you need to do? You need to fix your x. Then you fix your y depending on x. Fix your x first and then fix your y depending on that x. So how do you fix your x? X is going from where to where? From 0 to 2. Good. Okay, so if you look at different x, you can see that your y will, the interval for y changes. Okay, interval for y changes. What's the upper bound and lower bound for y in this case? Yeah, lower bound is x squared, upper bound is? Okay, good. Okay, good. Okay, so you can use iterated integral on this domain. Okay, so you can check that whether this makes sense or not. Okay, it makes sense. Why? Because when you integrate over y, you replace your y with x squared to x, and then everything was left in front of x, and then you do integration with respect to x. You're left with number in the end. Anyone try dx dy or not? Anyone try dx dy 有吗？没有，这么精深你知道了？更多东西有没？ 哪里东西要写啊？啊？x 在前面，后面还是前面？后面哦，OK。为什么 y 比较难？题目给的，What do you mean？题目没有教你 fix 哪一个 order 啊？Oh, right. Good, good, good. So, well, right, sure. So, okay, good. So this is a good point here. So the question already tells you y in terms of x. Yes. No, then sometimes the question could be tricky because maybe when you do the actual integral, actually is the other direction is easier. Maybe it's easier for you to find domain, but maybe the actual integral is harder. Who knows? Okay. So, okay, let's try. If you want to do dx dy, what do you need to do? Okay, so you fix your y first. Y going from where to where? Hmm? 0 to 4. Okay, so now you need to fix your x with respect to y here. So you also can see that if I move in y, how my x changes. Also bounded by these two curves here. Okay, so the left curve will be decided by half y. How about the other side? Should you use x equals to square root y or x equals to minus square root y? Square root y, right? Because the negative one will refer to the part of curve that is less than. That is on the other side of x equals to 0. Okay, so this is on the other side. Okay, so the upper bound is square root y. Okay, so you should go back and try these two iterated integral compute to the same number. Go and convince yourself. Okay, convince yourself. Okay. You see, you integrate over the same function, but you change the integration domain. Still compute to the same answer. Okay, so Fubini's theorem is kind of strong here. It's quite strong. Okay, so try compute the actual integral. Okay, right. See, should we try few more? Okay. Right. How about this one? Okay, I don't need to ask you to draw now. Let's quickly decide. What's the integration domain here? Well, let's say we already computed, okay, all the intersection point. Okay, we draw the diagram. So let's simply pick one direction. Let's say dx dy. Okay, so if we're gonna do dx dy, what are we doing here? So we need to fix the outermost domain first, okay, with numbers, and then we will let x depend on function in y. Okay, so y is going from where to where in this case here? Looking from the diagram. 2 to 4, good. Okay, so if you fix one slice of y, look at how x changes. Okay, when y increases, when y increases, x also increase. Okay, but increase in a different direction, right? So you kind of move your x interval here, but when you try to approach 4, it decreases again. Okay? So what's the bound here? Okay, so on the left hand side, what's the bound? The bound is square root. So the bound is square root 2x plus 6. And then the right hand side, the bound is x minus 1 here. 对吗？哦，sorry 反了，sorry 应该是用这张图，对不对？So on the left hand side should be half y square minus 3. And then on the other side is y plus. Okay. So do you know how to get this x equals to half y square minus 3? Okay, so you just try and manipulate your graph here, your curve. Okay. Okay. Okay, how about the other direction? So let's try the other direction. dy dx. Okay, so you're gonna fix x first and then you fix your y. So x ranges from where to where? If you see from this diagram here, x ranges from where to where? What's the smallest x? What's the largest x? Negative 3 to 5. Okay. And then how does y changes? Okay, so on one side, like what Jingsen say there, already tell you, okay, how to express y in terms of x. But the other side didn't tell you. Okay, didn't tell you, but how to find it? Actually, this y has two part here. Clear or not? So you can get y equals to square root plus minus 2x plus 6. I love the two parts here. So you need to see, okay, if I give you different x, okay, which part of graph is governing the lower bound and upper bound here. Okay, so if you fix x starting from -1 is just 1 point. Okay, but when you increase to 0, the interval kind of increase but get decreasing when you get to x equals to -1. And then decrease some more until you reach 1 point until 5. Okay, but how do you describe all these bounds? So can you notice that you can split this region into two parts here? Okay, so where's the two parts? How you split the two parts into? Where should you split it? 3 minus 1. So you split at x equals to -1. So you can see that the upper bound will follow the same curve, but the lower bound is different. So before x equals to -1, the lower bound is described by the other part of the parabola. But after x equals to -1, the lower bound is described by the other curve. Okay, so you split into two parts here. So let me draw the split here. So your y have two parts. I mean, split our x first. So one x going from -3 to -1, and then the other x going from -1 to 5. Okay, from -3 to -1, the y is controlled by the upper part and lower part of your parabola. So the lower bound is negative square root, and then the upper part is square root. How about the other side? It is the same upper bound, but the lower bound is different. Okay, different. Bounded by, in this case, x minus 1. Okay, so go back and try and compute the two iterated integral and then convince yourself that they are the same. Because Fubini tells you that it doesn't matter what order you do. Okay, no? Okay. All right. How about try one last one? Maybe you can take a break after this. Okay, try this one. We have volume of a tetrahedron bounded by this plate. Maybe just look at these four equations. See, you can draw out the tetrahedron. Just look at these four equations. So, well, I mean, how to look at this plane equation? You should figure out what's the normal vector. Okay, it will tell you how it's lengthened. Okay, try and work out the plane first. Okay, well, let's try. So how to draw this plane out? So let's reconstruct this picture here. Okay, so x, y, z. Okay, so the normal vector is 1, 2, and 1. So where does this direction live in? So 1 on this side, on the positive side of x, and then 2 on the positive side of y, and then 1 on the positive side of z. So your plane should face this way. Okay. So, well, I mean, you can check, does it intersect z-axis or not? Where does it intersect z-axis? Or to intersect z-axis means what? X and y is 0. Okay, when x and y is 0, z is 2. Okay, so 0, 0, 2 is one of the point of your plane. So where does it intersect xy plane? So how to intersect xy plane? So you set z equals to 0. Okay, if you set z equals 0, what is x plus 2y equals 2? Is a linear graph. Linear graph. It's a linear graph. What's this linear graph? X plus 2y. X plus 2y. So, okay, let me write down. So when z equals to 0, 2x plus 2y equals to 2. What do you get here? Y equals to uh, minus x minus x, right? That's 2 over 2. So I get something like this. So how do you draw this graph here? So this is a negative linear graph. So positive like this, right? Okay, so negative is on the other side, but you shifted up by 1. Okay, you shifted up by 1. So where do you intersect y axis? When x equals 0, y equals to 1. Okay, so you intersect here. It's 1 drawn there. And then on the other side, you should do what? Where is this? When y equals 0, x is equals to 1. X equals to 1. Sorry? Some more? Wait, let's check. So y equals 0 implies, yeah, you are right. So s equals to 2. So it's somewhere here. So yeah, it's 0, sorry, 2, 0, 0. Okay, so your plane looks something like this. Maybe don't use this. Use the other color. Yeah, a bit too far. Let's move it in. Okay, never mind. Okay, so your plane is like, I just draw a triangle, but you should imagine expand this triangle. Okay, so this is a plane. This is the first plane you have. Second plane, z. I mean x equals 0 and z equals to 0 is easier, right? So z equals 0 is just the xy plane. Okay, so you need a volume that bounded by these, right? So you got the xy plane. Where's the xy plane here? So maybe this part. Okay, x equals 0. X equals 0 is what plane? This one is zy plane. Z equals 0 is xy plane. Okay, so where is zy plane? So you got these wall here on the other side. Okay. So do you know how many things we had now? So we already had the one at the background, and then at the front, and then at the bottom, we have it. Okay, we still have the other wall to see. Okay, maybe I get rid of this green part. See, it's easier to see or not. get rid of that one. So put this one. And then this one, maybe we put dotted. This dotted line. Okay, so that one at the back. Is it easier to see? Can see it stand out or not? So this one is facing outside, and then this one is at the back, this one at the bottom. Okay, so we still have one wall to cover this tetrahedron. So what's this wall here? This is x equals to 2y. Okay, so x equals 2y means what? So on the xy plane here, how is to draw x equals to 2y? Or you can understand it as y equals to 2x. So y equals to x on this side here. I guess 2y equals to x over 2, meaning you just make it less lengthened. So maybe like this. Okay, so let's cut it. Cut it like this. Y equals to 2x. In particular, when you cut through this plane, what's the intersection here? Y equals to x over 2. Implies what? X over 2 equals to, let's compute out what's the intersection here. When y equals to x over 2, if you put it back to your plane, on the xy plane, what do you get? Okay, 是 x equals to 1. Okay, when x equals to 1 implies that y equals to half. Okay, so exactly is what computed on the. Can you see or not? Yes. And so this is kind of important, how to get this intersection, how to see line and plane intersect. Kind of important in this course. 51. Any question? I think so. Know what we are doing? Can try and repeat. No need, just about y. X equals to 2y intersecting the plane x plus 2y plus z. How to find the intersection? So, x squared. Which function? Read the function out. X minus x over 2 plus a. Why do you want to substitute to that one? That line. What line? The y line? That line. Second, what's the y line? Is that a line? Why? Okay, so my question was taking x equals to 2y line to intersect x plus 2y plus z equals 2, right? So intersect the plane. But why instead you intersect with that line, that particular line? Come on. Did you think about this? Why not put into the plane? Why just put into that line? It's not that reason. Whatever you say is true, but not the exact reason. Why that point has z equals 0? Why? Why are we looking at z equals 0 in this case? 啊，我们有一个 plan z x y plan，又怎样？我们本来就有啊，是吧？然后 where this intersection live in 啊？对，但是不准确。Where does intersection live in? Yes, on xy plane. So if your intersection live in xy plane mean what? Means what? The z have to be 0? Okay or not? So the plane, when you put z equals 0, will reduce to the line. 合理吗？你觉得？一个 plane you reduce one variable 变成一条线了，是什么意思？z equals 0是什么东西？Yeah, sure, level curve is xy plane. So whenever you do this kind of substitution, you are looking at the intersection of the two plane. 上次跟你们讨论过了，对不对？ If you intersect two surface together, the intersection of the surface has dimension lower than what you started with. So it becomes a line. Okay, ma. So now, whenever you do intersection, in this course, you should think of it as an intersection of two surfaces. Okay, so when you do z equals 0 substitution means what? You are taking a xy plane intersect with your surface. Your plane. So intersection of two planes, in this case, you get a line. So what's that line? That line is y equals to minus x over 2 plus 1. Okay. 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 But if you look at this, s equals to 2y, it says that this is a surface on on uh, on surface on R3. Okay, in R3. So what kind of surface is this? It is a plane actually. Okay, it is a plane. Because this equation here doesn't tell you what z to take. So meaning what? You can take every z. So every z you have this line here. Okay, so it will form a plane. Okay, does it make sense? So what line I draw here, this line is just correspond to z equals to 0. Okay, so if you put all these together, it will form a plane. Okay, so it cover up the other side of your tetrahedron here. Do you know that why x equals 0 is z? Okay, let me ask you. Do you know why that z equals 0 is an xy plane? You know why? Huh? It consists all the point x, y, z such that z equals to 0. So where this point live in? This point exactly live on the xy plane. Okay, exactly on the xy plane. Because you are free to take any x and any y. Okay, you're free to take any. Okay, right. So if you want to find this volume, right, bounded by this plane, how should you do it? How should you do it? To use our method just now. So you need to decide your f. You need to decide your domain. So what's the f and domain you should decide here? They didn't tell you, right? So what f and what domain you need to decide? So can you imagine this volume as a volume under any surface? Which surface you think? Which part of the plane can become your surface? Hmm? So potentially you can get function from this plane here. Yeah, how to get the function from this plane? How to create the function of two variables here? So which one is dependent on which? Which variable is dependent on which in this case? X, Y dependent. Yeah, Z dependent on xy. Okay, z dependent on xy here. So, well, you can form fxy equals to z, which is equals to 2 minus x plus 2y. But like what we did just now, right? If you just look at the real plane of this, it will cover more than what you need here. Okay, it will cover more than what you need, correct or not? The plane will intersect out to 200. But you are cut by another plane. How do we take this into consideration? How do we take this cutting into consideration? If you just compute volume under this curve here, you will potentially compute everything up to 200. But it is cut halfway. How do you take this into account? Instead of taking the whole area under this plane, you need to reduce your domain here. Okay, you need to reduce this domain here. How to reduce this domain? Can you try and draw it out? Okay, so if you try and draw this triangle out, how do you draw it? You should bring out your xy plane. Okay, you should bring out your xy plane. So if you bring out your xy plane, you can see that on the y-axis, you are integrate from 0 to 1. But how do you control these edges? How to control these edges? Where these edges came from? Okay, where these edges came from? So basically here got two edges, right? So you need to decide where these two edges from. Okay, so let's look at the left one first. Where these edges come from? I'm Ping Xiong again. Where these edges come from? So this edges will come from the plane x plus 2y plus z equals to 2. Okay. Okay, so come from this plane intersection here. How about this edges, the left edges? Who supplied this left edges? Enzi. Who supplied this left edges here? X equals to 2y. Okay, so exactly this line is supplied by x equals to 2y. Okay, so here written y equals to x over 2 is the same. Okay, so now what do? You need to decide your order. So whether you want to differentiate with respect to x first or you want to differentiate with respect to y. Okay. Are you okay to write it out or we need to go through together? You want to choose one, go through together, or you are okay? You have given the lecture already. Want to try one direction? Maybe ask you to try. Like we can try dx dy. 呀，减二，什么是减二？哦，减二 y 哈。Okay, thank you. Okay, so let's like we can try dx dy. How to determine the integration domain? If you given this picture already. 什么？要哦，Okay. Maybe change the other one. 小羊呢？Oh, y first, y first. Yeah. Wait, so if you're gonna integrate dx dy, okay, so how do you fix your y? Your y should be fixed by a number first. Good. Now, only then you decide x with respect to y. Okay, so x with respect to y is what? X going from where to where? Minus 2y. X equal to 2 minus 2y. And then on the other side? The side is 2y. So which one is upper bound? Which one is lower bound? Which one greater? Which one smaller? 2 minus 2y, do you think 2 minus 2y is greater 1? Well, I mean, so let's draw this. Let's draw this. Okay, let's draw it. So if you fix a y, what happened to your x? So let's start from y equals to 0. If you start from y equals to 0, how your s changes? Only has one point. But when y increases, x also increase. But if you look at y equals to half, what happened? After y equals to half, the x interval will decrease. Okay, so how do you describe these interval? Actually, this interval are controlled by two parts. Right or not? So there are two parts here. So this part and then the other part. So which side is smaller? Smaller side is what? This line, lower bound, controlled by what? Is this line? What's this straight line? How do you call this straight line here? Vertical line. 啊，什么？这条线，这条线叫不出来。这条线要符合什么？S equals to zero，对吗？在这条线上面 S 全部是零的。OK，so the lower bound is 从这里去这里嘛，lower bound 是 x 等于零。OK，upper bound 呢？There are two types of upper bound, right? So it follows x equals to 2y up to half, and then follow the other curve. X equals to 2 minus 2y. So actually there are two parts. Let's say there are two parts here. So let's write it up. So we split y into two parts. One is 0 to 1 over 2. And then the other one is 1 over 2 to 1. So for one side, you have x going from 0 to 2y. The other one, you get 0 to 2 minus 2y. Okay. So there are two parts. Let me draw this. Okay. Okay, does it make sense? The integration domain, if you put it into the x variable, you integrate x and then you substitute by y. Then in the end, you integrate over y. So you get a number. Okay, how about on the other side? dy dx. Let's get the other table. Let's get let's say we're gonna do dy dx. So we need to fix the outer variable first. X going from where to where? 0到1啊. Good. So how does y depend on x? So what so doing dy dx, what's the slice here? So when you fix an x, you see how the y changes. Okay, so you can see that the y decrease all the way up to a point to the end. So what's the upper bound and the lower bound here? So y 到1减 x over 2. Okay. 看一下 make 不 make sense See make sense or not? Okay, on the other side, depend on x. But on the right side, depend on y. Then 这个2y 会跟这个 y 一起变吗？好。X over 2. Okay, so x over 2 is this line here. And then the other side is correct or not? Yeah. 我写错了，应该是 1 minus x over 2. Okay, upper bound is the top curve here. Yeah. Okay. If you want to think of it, you can call this y1 and then this one y2. Okay, so it's bounded below by y2 and then bounded above by y1. Two curve. Okay, y1, y2. Okay, or not? Okay, to be precise, these are two curves. Okay, so I'll go back, try to compute the integral. Any question? 有问题吗？No. Okay, if not, let's take a break until 10:20. 要想问一下，川宇，有看到小莹吗？拜三的时候小莹就没听过了。周三你们有看到小莹？没有，不是？好像我也没有看到。OK，姐，你 project 交了吗？在做着。交。周末啊？OK。因为你今天这样早来的。哦，没有睡。OK。哎，Hello，苍云。哎，苍云 project 还没交。哎，不是，在那个摩登那边的。他是你来，我看你。红姐，你长得很像一个动漫里面的人物。刚刚有看过那个去找的一个人叫无常。这样很像。所以你我删一下。那好上。OK，但是我想录下来，你就打一下就这样，然后你的我的 and then 然后放一个推理，放过吗？放过，然后你现在不要那种整句例子被开朗起来，如果整句句子被开起来，你要开要画这个字这里看。然后如果是 definition 被画起来就那个的话，OK 吗？我觉得好嘞，这是东西。 哪一个 project 啊？怎么嘞？应该看你什么变化来吧。你可能太少是具体是也有道理。If I got time in the afternoon, maybe I can answer the question on the second derivative test. If not, I just tell you only. If the others is not interested. Mhm. The other thing is there's a quiz. This one. Maybe you can try and move your brain a bit. Huh? So here is equal actually. Huh? Why? 不是25哎，我也是一开始25，就是当你看到这两个数字，不是，如果你没有去看等于啊，你就很容易去想，是不是就乘5就好？Actually，等于很重要。Okay, so if you just try to guess 25是个 S，是 S。哦。Okay, so if you try to just see the number without look at the equality, you will easily form your own pattern. Okay, but it's not the pattern that question one. Okay. So I mean，如果写成这个1等于5啊，其实你知道你在用什么理论吗？模具逻辑？不是，模具逻辑。不是，check 一下，modulo 几？modulo what? It's 4 is a modulo 4。算一下是不是 modulo 4？5跟1一样，2跟10一样，is differ by a multiple of 4。Sorry，可以吗？看一下，25减5哦，也可以，Yeah，in this case 也可以，也可以。如果用 modulo 4也可以，对。把这里没有讲啊，这里没有讲吧？I mean，如果就单单看这个的话，其实没有关系，对不对？后面跟前面没有关系，exactly 就是因为1等于5等于8，后面东西可以丢了，其实。OK，Yeah，OK。maybe，哎，Hello，怎么你刚来？吹过头，OK。Do you want to discuss project 2 or next week? We talk about this. 啊，next week 啦，哈，next week，next week，next week only talk about it. You can do other stuff. 哈？What？你要开始准备啊？可以啊，也可以。Okay, so basically, project 2 is kind of direct. You just need two parts. Okay, one is problem statement, the other is solution. Okay, problem statement and solution. So what's the project 2 about? It's about real life application of actually this theory, calculus 2 theory. So in your problem, you should use calculus 2 knowledge to solve it. Okay, to solve it. So I have some project recommendation here. So for example, you can do Apple airport noise cancelling. So why you can do cancellation? Active noise cancellation. Actually, it's not cancelling the noise, you know. It is producing another noise that cancel out the ambient sound. Okay, so actually it takes in the ambient sound first, and then it produces a negative coefficient, for example, negative coefficient for your sound wave outside. Right? Because in Fourier series, what we do, we split sound wave into bunch of linear combination of sine wave and cosine wave. Okay, so the coefficient will decide what sounds it is. Okay, so if you put a negative of that coefficient, if you add two together, do you get a zero function or not? So that is the no sound that you listen. So you can do Fourier series in sound technology, not just Apple. Nowadays got what Sony and then JBL got no JBL got, and then Sennheiser 什么啊？没有，什么？Oh yeah, we will get into it later. And then the other one is Ramanujan summation in quantum physics. So maybe you can talk about Bose statistics, so on. And we have just gone through double integral, right? You should have seen double integral in your statistic, right? And then you can talk about maybe higher dimensional probability. And how about continuity? Okay, so continuity will be used in image processing. For example, GoPro uses hyper smooth image stabilization. Do you know what it means? So if you take your GoPro and run, your image won't shake one because stabilizing. And actually, talk about this. I want to talk about this newest technology here, which you can discuss. This is by Adobe. This project is called a turntable. I'm not sure you know or not. You draw a 2D shape in Adobe, and then you just turn the cursor around that photo, it will make it into 3D. It will kind of complete the 3D shape of your 2D picture here. Okay, I show you how they do it. And then I show you how they present it. Actually, I want you to present your project like what they did. You see now only 3 minutes, 5 minutes only. You know how many effort they put in, maybe years, you know. But in 5 minutes, they have to finish it. Okay, so this is an idea and concept that I want you to do in the presentation. Okay. So let me show you this presentation. Hey, where's the? Oh, I think it's in.
See? Yes. This is our final snake, and it's going to turn this place upside down. Please welcome our final presenter, Jun Chin Chen with Project Turncycle.
Thank you, Halsey. Good evening, everyone. I'm to share this new tool I have developed for Illustrator. Now, I'm working on this scene. I have the shape of a dragon and a warrior. Now, I want warrior to fight the dragon. But I suddenly realized that the warrior is looking at the wrong direction. The warrior should be looking at the dragon, right? So I have to turn the warrior around to face the dragon. But you see, it's a 2D vector shape. And I cannot just turn it around. Now, normally, I have to redraw the entire shape, which is going to take a lot of time. But here, let me show you our new tool. I'll just need to select the shape and click this Select Views button. And then I can just rotate the shape by simply dragging the slider. Thank you, thank you. I love this audience. Yeah, that's it. That's how you do rotation. Okay. Now let's also try the dragon. Just select the dragon and click this button. Let's wait for the progress bar to finish. Then I can just turn the dragon around like this. And keep in mind that all the shapes are still vectors, so I can still edit them after rotation. Now, let me show some more examples because our tool is quite powerful. So our tool can handle different artistic styles. For example, this basket of bread. This bright sky. Finish yet. Yeah, we have seen a lot of horizontal rotations, so it shouldn't be a surprise that our tool can also do vertical rotations. See if it is a 3D shape.
Wow.
Here you go. Okay, now let's see what we can do with both horizontal and vertical rotation. So here I have the same shape that first scene, but now I want to view the scene from a high.
Okay, I think it's enough. You can go back and look for it. It's called a projection table. Well, if you listen to this presentation, you can pick its flow. For example, the pronunciation, but it's okay. Okay, so if you pronounce not good or what English grammar not good, it's fine. But what I want to see is your self-esteem. How to speak something clearly, like him, and present the idea clear. The English pronunciation a bit wrong or grammar a bit wrong is fine, but your idea must be clear. Okay, your idea must be clear. And then this project actually is a miracle, you know. 这个奇迹来的。 How can you just see one side and then you know what the other side looks like? Even human cannot do it, you know. 比如说我天天只看到箭筒的这一边，我怎么知道它另外一边有什么东西 ？Well, I mean, they obviously use symmetry to do it. 假设你另外一边可能这里有个字，这里可能也有一个字哦。You get what I mean? So I mean, this is still a miracle. Yet, still a miracle. If you look at the just now the what the bread, right? If you just look at this bread, it is not symmetric. You turn below, it's not bread anymore. How do you know you need to close it up? Okay, so it's kind of miracle here. So you can talk about this. How to go from 2D vector to 3D vector. Okay, kind of continuously. This is also what is done in your Apple AI, right? 几个人用 iPhone 啊？这边有人用 iPhone 吗？几个人用 iPhone？Who use iPhone? Yeah. So now there's an Apple AI, right? In your photo, you can remove the person in the background. Okay, but when it removed, how does the AI know how to fill it in? How the AI need to fill it in? So you need to fill it in continuously, right? So that you will see that, hey, there's a hole there. So you need to somehow fill it continuously so that it looks natural. Okay, so this is what the continuity useful here. Okay, no. So you can try and go and research and then see what's the maths behind the use. Okay, that related to calculus. Okay, so the other one, astronomy. Okay, orbit. Why I put the orbit of Mercury here? Because orbit of Mercury kind of mysterious, because this is the orbit that doesn't follow the Newton's gravity calculation. Okay, but follow the Einstein general relativity calculation. Okay, the other one is arcs. Okay, Mona Lisa. Why is it so nice? And then they've actually found Fibonacci sequence inside Mona Lisa. Okay, and also a lot of architecture, the ancient architecture. For example, the what's the Athens? Is it called the Athens? The Athens in Greek. Athens. 看过吗？知道我讲吗？ Yeah, yeah. So maybe I show you the picture. Yeah, this Athens why 它是八大奇迹之一嘛？七大还是几大？啊？几个奇迹啊？一个seven wonders, yeah, seven wonders. Why it can stand until today? Is there a max behind architecture or not? Sorry? Yeah, 它有一个 corner 是不是 ？Yeah. So I mean, yeah. Why is it? 为什么它伟大？为什么人家要把它保存起来还是什么这样？ And also you can look for others buildings actually not just this one. Also the a lot of pagoda. You know what pagoda is? 塔 yeah 那种中国的那种什么塔 pagoda. What's the Chinese pagoda? Yeah, this kind of pagoda. What's called in Chinese? Okay. Pagoda. Yeah. So why they build it like this? Any mathematics significance or not? Okay, and then obviously another wonder, Egypt, the Great Pyramids. Again, they use the Pythagoras theorem. Okay, and then yeah, this one. Also sports, right? Sports. So what do I mean? By these are normal vector of tangent plane here. Because for example, if you play badminton, ping pong, what do you use? You use a bat, right? The bat. So when you want to smash, can you smash like this? Cannot smash like that, right? So your bat must face down. Why face down? Because the normal vector to the bat is going down. Okay, so your shuttle should follow the normal tangent. Okay, yeah. And then yesterday, right, I suggest to no need to do also. Okay, I just suggestion. Bing Xiong, yeah, Bing Xiong. Because you do frisbee, right? So how do you throw frisbee? How do you draw frisbee? Right, so you just throw it. Maybe this frisbee fly like this. But what is this? This traces out a curve in 3D space. Okay, so if you consider the old curve, right, what this curve will form? Actually, this curve will form some sort of ellipse or ellipsoid. But do you learn how to give the ellipsoid equation or not? What is it? X squared over a squared plus x squared over, sorry, y squared over b squared equals to 1. Okay. But you just want a single curve, meaning what? You are intersecting this ellipsoid surface with a plane. Okay, maybe what is this plane? Maybe this plane is x plus y plus z equals to 1, for example. Okay, so if you equate, let the point sitting on these two sitting in this two shape here, then you will get the plot you want. Hey, ellipsoid is not look like that, right? That one is just ellipse. What is ellipsoid? You need one more z, z squared over c squared. Okay, so if you equate these two together, then you will get a equation for integral of x and y. Integral of x and y means what? Is a curve. So you will get the intersection of this curve. Maybe you'll get the other side because ellipsoid is the whole ellipse. Whole like a distorted circle. So you get intersection on the other side. So that's why your intersection will have x squared, y squared inside. But you just get one side because your frisbee won't go underground, right? So you just keep one side. Okay. Maybe it's circle or ellipsoid. In general, ellipsoid. Depends. Yeah, ideally, maybe. Yeah, you can try. This is just an idea. Yeah, just an idea. So your idea should start simple, and then you go into it. Modify it. Yeah, your idea should be simple. 不要直接就来一个最难的把自己弄死了。怎么把自己弄死？没有必要嘛，对不对？从简单的开始做，然后我们发现到，可以再走难一点，可以再走难一点，再走难一点。This is how we do research。不可能拿一个很大的题目弄死掉自己，把自己弄死掉，对不对？没有必要嘛。OK 吗 ？But in your case is different. In your case is different. 在你的世界里，你觉得你要死啊？其实我在现在，你就不要问我。对，我在现在是你还有我的世界，而不是你罢了，对不对 ？Obviously, I want you to work first, and then 你 start， 你来找我。除非连我都讲很难，比如说 Isaac 的那个题目，我也受不了我也受不了，你那很难，我也受不了。So 怎样办？我们就 stop 在那个 technical point 那边咯。That's all。我 happy， 你 OK， 那就好了。That's all。Yeah。OK 吗？问题吗 ？OK 吗？可以吗 ？Are you sure? You don't know how to do this? How to do what you need to do? 就拿一个 real life problem statement 问一个问题 ，solution solved by calculus。OK。好多我讲一面可能你要读很多东西，把你的东西写成一面就够了。OK， 写一面不代表你读一面嘛，你要读很多东西，但是你写的东西就一面。OK 了。Okay, so after you write out this report, you still need to make a Beamer project. Okay, so you need to make Beamer presentation. So Beamer is almost the same as your report. You just take your text from your report. Maybe you add some more diagram or what, or you want to show it on the spot also can. Yeah, you want to do practical presentation also can. So presentation part, is the main thing here. You only have 1 minute, okay? If you are very interesting, I give you 0.5 minutes extra. Okay, just 1 minute. So your Beamer also no need long one. Okay, from past experience, I'm mod 6 already because 10 seconds change one slide is quite fast already. Okay, and then the main part of this presentation is Q&A. So your classmate get to ask you. Okay, everyone will train to answer question and ask question. Okay, so if you ask good question, you will get extra mark inside presentation. Extra, this is extra. Okay, if you ask good question to your classmate, then you'll get extra marks. And then after the presentation, you should tell us two questions. You have to answer two questions here. So one question is, how do you convince the layman maths is useful to study? Okay, so tell a non-maths student why maths is useful to study. And then the other one is, I want you to think about why you first choose the maths degree to study. Okay, so you need to think about these two questions to answer. Yeah. So you will be marked with your language and completeness of your presentation. So what's your logic flow there? So does it make sense or not, whatever you say? Okay, and then lastly, what's the flexibility you have? So can you answer question or can you take question properly from the audience? How you answer it. So I mean, accuracy is not that important in this case. Maybe you will say something wrong, but I want to see how your response. Okay, if you know something is correct or wrong, or do you just yeah, want to say? So I just want to say your response on the spot response. So you can earn up to 2 extra marks if you ask good question. Extra marks of course cannot exceed 5 your total marks. Okay. So well, I mean, you can invite your friends to come, or you can invite your supervisor to come, or your teacher lecturer to come. Yeah. So if you want to do FYP with this teacher, right? Maybe you want to make a good impression, you can ask them to come. Also your academic supervisor. Call academic supervisor. 是吗？是叫 academic supervisor. Advisor. Yeah, you can call your advisor to come over. Yeah, to see how you learn, how you are doing. Okay, inside the course. Okay, you are free to ask your friend to come. So this is an open seminar. Okay. You want to ask your family to come also can. Yeah. Okay. Okay, so you will be presenting your project. Any question or not? Question? This presentation, okay, very good question. I think we want to make it on the week 14. 14 Friday. Is it okay? 14 Friday. You said that you guys only free on Friday evening, right? All the other evening you got class or what? Friday evening, good. Week 14 evening. I think we only need 2 hours because your cohort is small. So how many time we need? Let's say maximum 4 times 25. 100. 15, 20, 18, 100. About 2 hours. I think 2 hours is enough. Okay or not? Friday, week 14. Maybe 7 to 9. 7 to 9. Week 14. Is it okay? If okay, then we will book the room. Week 14. We'll try and book lecture hall. I think draft is not so fast. Question is also not so fast. You can think about, you have few more weeks to think about. Maybe next week or the week after, we can start collecting your problem. And then we will also list it up so that no clash. For a series. You can think about. If you are really, really sure, you can send me first. But you have time to think about. 1 to 2 weeks. Maybe after assignment 14. When do you need to submit assignment 14? Week 12. Week 12, week 12, right? Maybe we can start collect question next week after assignment. Yeah, I can think about first. No need hurry. But if you already fixed, 已经定了你的心意, you can tell me. Try not to clash so that we have a variety inside the class. Okay. Yeah. So if you are a finance person, you want to go and look for finance one, it's okay. Anything, as long as you use calculus 2. Okay, knowledge. As long as you use calculus 2. Okay. Wow, I spent about 1 hour to talk about this thing. Okay, maybe we just cover up last part of double integral and then we can take a break before we go to polar coordinate. So property of double integral, if the two domain doesn't overlap except on the boundary, then you can split this integral out. Actually, we are kind of using this already, right? You know, when we do changing the order, we're splitting our domain. This, we are doing this actually. Okay, so it is valid to do it. Okay, as long as your domain doesn't intersect too much. What do we mean by too much? So only on the you can only intersect on the boundary. So the intersection is a line. Okay, something in the lower dimension. Okay, second, double integral of one of a area is area of the domain. Can you think of this is why is this true? Because every time we talk about is a volume under the surface, right? But why become area in this case? Why? The main point is 1 here, huh? Yeah. Correct. So because the height here is 1. Okay, so what's the box? What's the volume of a box with height 1? It's actually equal to the area. Right. So let me draw this out. So if you have a box like this, and then the height is, let's say the height is 1 here. So bottom here is the area. So volume is A times 1, which is A. Okay. So if the height is 1, what you compute is really just the area of the domain. Okay, this fact is kind of useful sometimes if you want to compute the surface to be a constant one. Third, third is if your fxy is bounded by two constants here, small n and big M here, the double integral of f is also bounded by something related to bn and small m here. So what's the bn and small m here? This is the volume of the volume of what? Volume of the surface, okay, with height small n and big M, okay, times the area of D. So how to prove these? How to prove this? Previously, we know that whenever we have f less than or equal to g, this implies what? Double integral of f is less than or equals to double integral of g. Okay, but in this case here, what's your g? Yeah, what's your g? Your g is capital M, and on the other side is small m. So this will imply that the double integral of small m dA is less than or equal to double integral of f of dA, and less than or equal to double integral of capital M dA. And because m and m are just scalar, right? So what do we have? Another property we had on double integral. Double integral is linear. So you can pull the scalar up. Okay, so if you pull the scalar out, what do you left with? You just left with a 1. Function 1 inside. But just now we said that if you integrate over 1, you will get the area. Okay. Okay, so these are the property. Actually, we are using it, but you are not realizing, maybe, right? We didn't mention just now. We just speak whatever we like. But actually, we can. Okay, we can only when the intersection is aligned. Hey, by the way, just now we was skeptical about the atoms, right? Actually, there are people doing research on that building, so they try to relate Fibonacci sequence to that building. Maybe you can read about it. I'm not sure how true it is, but what I want to do is you try and research what people do. About why it get rotted, become now. I mean, there are a lot of reasons, right? Maybe it's not just the reason of the structure itself. Maybe it's the climate or human how to say, human activities like that. For example, for pyramid, when people go and visit, right, they can enter, but now they don't allow enter anymore, or they don't allow climbing anymore. because if there's no maintenance and then they do something that's not expected by the builder, then maybe you will destroy the building. Yeah. So there are a lot of reasons why it get destroyed. But what we do is we try to find the reason why it still exists. Yeah, something like that. Okay, so the point of research is I mean at your stage, because you don't really do research yet, right? So now you are just reading what people are researching. Why people think that that's true. Yeah, so you're just doing that. Okay, instead of doing real research. Okay. Yeah. Okay, so I mean basically I think so far it's like this for this double integral for rectangular coordinate. So in the next hour, we'll do a double integral on polar coordinate. And we'll see how we do this. Okay, let's take a break until 11:01. Mhm.什么？他问吗？没有，你可以讲 I can go back and think about it. You can go next. I can go back and think about it.
I wouldn't be okay next.
其实有时候你也可以放忽悠这样，放忽悠，就讲你会的东西就好，就讲你会的。
我是这样提出来的，应该不是这样提的。他会出一个回答，就算你不管多高多高，他这个角。道理比这些吧。
一定是有包含损失啊，都包进去了。
不是一个包可能不呢？依然是 eccentricity 影响我一个。他妈是，哎，他不能变，他不能知道。
这样才是一定是。
没是。闪
呀，
闪给你，
不是你可以问回答，你不用这样回答。
因为我今天算，我要问回。有点是到底是不中文这个我
对呀，
对，然后再
因为有时候人家问的问题他不回答，你要回答。 什么什么？
原本以为那个发现最大的坑是那，而且太大坑了，这个发现。
大，因为不 trivial 嘛，那种。
哦，
它东西不 trivial。那想想看啊，你那个无限这东西也可以这样子继承下去，变回来，
是
是
因为想到还是对，就是你的心情变这来的，
那直接
后来你们导致为什么你们发现，然后你是做你他的坑，
对，没有人舔过吗？没有人，
觉得我 knowledge 还没有到可以
但是没有，你可以看不到是
就是
那个 statement
啊，对
对呀，比较重要是看懂 statement，statement 看懂了才开始。对，哎，你好，真的找不到，看这个。哎，我没有什么去学，我想找不到哎，找到你怎样找不到的？口管是哪一个喜欢看到？对呀，那这个有钱，对不对？哎，天呐，就是，就是看嘛，我把你这边抓的是你贴，把你这边抓，这个去，先别说了，拿走吧，知道死，我去，吃饭，还是他，谁呀？不要相信我吧，我们那个做这个，你看我，是这样子的，有一次，然后你们做狗一样的。你是自己给他的那个底，现在简单的吧？第一啊，我们是先转一转。那怎么比如果比赛的话，不是？对对，那给我这个，他是做这个，你是做，我是这个知道。我这哦，有没有想过这个？OK，我讲，我就做这个，非常有简单。哎，谁？说那个谁对我的发，那讲讲看。这个我不考虑那空气摩擦就是重点的。对，行行行，哎，你现在没有啊？你好，你说，然后不要再跟我抢啊！你们真的，我把你在时间跟利用，我真的，你帮我找个我抽烟啊！他自己选的，哎，不是那你讲要选一个呀，有什么想法？你告诉我选一个，跟我老公只有那个，一个，我这个钱，我是不做啊。然后我也没有，上班的时候没有讲，我每天换一个省图，这个应该是这样。是我一生求下到，这样，他想哦，这样，这个。那个完全找不到，我这个一手有到，然后弟弟也是懂得有点转，然后跟他转，这个应该是这样转。
我一张我这了，这是那个你们都在同一个东西，我都在牛排。一查到什么去
？Okay, ready to start? All right. So now we're gonna integrate into a polar coordinate. So we'll try to understand this polar coordinate here. So previously, what we do, we relate this a to a rectangular coordinate, which is dx dy. But now we try to change the integral to dr d theta. So if you notice, when you do this, this is the polar coordinate substitution we do, right? X equals to r cos theta, y equals to r sin theta. But there's an extra r there. Okay. Later we will explain in general how this extra factor come out. But now I will use the other way to tell you where this the extra r come out. So the main point between rectangular integration and polar integration here is after you substitution, you must multiply the extra factor r here. You must. So I will tell you how this r comes up now. Okay. Later we will use a general way to see how this r come out. Right. So if I write like this, right, what can you see here? How the integration domain r and theta get controlled? Can you straight away see from this r ranging from where to where? From where to where? A to B. Okay, small a to small b. Theta? Alpha to beta. So how to draw this rectangle? How to draw this rectangle? So let's pull out our xy plane. So radius is going from A to B. So let's say like this. A to B. Angle from alpha to beta. So let's put an alpha first. Maybe alpha is like here. Maybe beta. Beta a bit more. So where's this rectangle here? Can you imagine? This is a slices of pizza like that. Okay, but removing the part before A. Okay, so this is the rectangle that you look at. Is this kind of different rectangle or not that we see before? Different, right? Because the side is kind of curved on one side. Two sides actually. Two sides is curved. But can you imagine that if I take smaller and smaller polar rectangle, actually looks like rectangle. Because the curved side getting straighter and straighter, right? Okay, so it's kind of calculating the same thing when you take limit to smaller and smaller polar rectangle. Okay, imagine. So I mean, if you want to look at this picture here, so you can slice out your polar rectangle to smaller and smaller rectangle, then actually it looks like a rectangle. Okay, I mean the proper rectangle. Okay, so this R actually is capturing the factor that how you relate this curved rectangle or the polar rectangle to the rectangular rectangle. Okay, so let's see. So how do you compute the area of this? I mean, area of cuboid is easy, right? You just take width and length. But here, how to compute? How to compute others? Actually, you don't know how to compute this piece here, but you know how to compute a proper slices of pizza. How to compute? If you want to get this shaded region. I think high school like to give this question, right? So what's the area of this? Is the larger pizza slice take away the smaller pizza slice here. Okay, but what's the theta you are using here? Actually, this is the difference between alpha and beta. So you take beta minus alpha here. Okay, but I mean, if you split this difference of square up, what do you get? B plus A times B minus A times beta minus A. So the difference here is what? B minus A is a different in R. Beta minus alpha is a different in theta. And then you have an extra factor here, which is the average of the radius, which does not call it R bar. Okay, so this is the extra factor that come out. Okay, when you're trying to compute the area. Okay or not? So delta R, delta theta here, you can think of the dr d theta. Okay, so the extra factor is actually the average of the radius. So there's a extra factor coming up with your delta R and delta theta. Okay, so please remember there's an extra factor R when we try to do polar integration. Any question so far? You want him? Yes, yes. What do you mean? Okay, okay.
In the equation, there's a
Oh, you mean this R? You mean this R?
Yeah.
You mean this R?
No.
Which one?
The one the end of the equation.
You mean this R?
No.
Which one?
The action.
The
R.
你说这个啊？你说这个啊？Actually, yeah, right. Sorry. I mean this R. Right. Actually, I'm not precise how to go from R bar to R. I'm just trying to tell you that there's an extra factor R coming up. There's an extra factor coming up when you compute the area of R in this case, big R here. There's an extra factor here. So I didn't really tell you the path from R bar to R yet. So later we'll use a general way to talk about it, which is Jacobian. Later we'll show you that Jacobian of something is this R. Jacobian. Yeah. I haven't really tell you the real path. I'm just hinting you that this R is popping up whenever we try to compute the area of a polar region. I didn't tell you why we have to put R. I cannot say like that. I want to say that I just want to say it's not a precise way to say why R come out like that. There's a more precise way to do it, which is Jacobian later. Yeah. We can change coordinate to different coordinate, not just polar. We can do something else. Maybe just a shift also can. Then it will affect by the Jacobian. And then in this case, the Jacobian is R. In different case, Jacobian will be depend on how you do it. Later we'll do it in more general. And then I'll show you why this R pop up. Yeah. For now, I'm just telling you that if you compute area of polar, then there's something extra outside the dr d theta. Something extra. And then we make it up. Okay. Okay. All right. So let's see how to compute this. So again, same. Okay. Double integral of this two-variable function here. But what's the region here? How to draw this region here? So this is a region on the upper half plane. So let's draw the upper half plane. Upper half plane means what? Only on the top here. Okay. Bounded by a circle. What's this circle? This circle you shouldn't forget, right? This is what? The unit circle centered at the origin. But only one side, right? Because upper. Or can you describe more precisely this curve here? Xiao Yang. Can you describe more precisely what curve is this? The upper semicircle. Y equals to what? Good. Y minus. That's correct. Good. Okay, so the positive side, because y is positive, right? So negative one, you need negative square root. And then the other one, x squared plus y squared equals to 4, meaning what? This upper circle is a larger radius. Okay, so you need a larger radius one. So instead of drawing the larger radius, because I am out of space, so I draw a smaller one. So this one is for y equals to square root. 1 minus x squared. And then the outer one is y equals to square root of 4 minus. Okay. Well, I mean, in this case here, if you live in the dy dx world, right, what can you do? You start and choose your order, right? If you want to do it dy dx, let's say, what do you need to fix here? You need to fix your x first and then fix your y depending on x. Where is your x? Going from where to where? You find all the intersection now? Because this is a radius 4, right? Center is 0. I think you can quickly find the intersection with x-axis. So the outer one is 4, 0. Correct, no? The other side is minus 2. Sorry. 2, 0. And the other side is minus 2, 0. Okay. And then in the inner one, you have 1, 0, and negative 1, 0. Okay. If you don't believe me, you just sub your y equals to 0 and then go and find your x. Okay. Right. So where your x ranging from? Where your s range from? Okay, wait. Before all that, let's draw this r first, so that we are not confused. So r is just this part here. It's like a donut. Half of a donut. Or it's like a peach. Have you seen peach like this before? Okay, the peach I mean is the tin peach. 看过吗？那个说糖水的那个 peach， 是不是被压到这样？不是被压吧？它应该是被切到这样。有看过吗？啊，怎么来的？没有喝过啊？你们？你们看一下。对啦。哎，这种吃过吧？You try this? You try this before in your dessert or anyway? No 没喝过。哎，这个很好喝哎，如果你加龙眼放饼，我们东马人都是这样喝，我们东马人都是这样，然后我们放100 plus，100 plus with this with 龙眼with ice, very nice. Every time Chinese New Year festival, we make this for family and friends. Yeah. 虽然你看到这个是有盖起来，有一种是就是一片一片 slice。Yeah. Anyway, yeah, 这个是 yeah. Okay. So let's compare to this. So where's your x? Is your x ranging from -2 to 2 or not? Is it from -2 to 2 in this case? Do you take everything inside -2 to 2? No. How you split it? Okay, -2 to -1, 1 to 2. But after a certain y, right, you change again. Okay. So, well, I mean, in this case here, you should take all of them first. And then y will help you to take care of them. Okay, let's try. Let's try first. So let's say we want to take -2 to 2 first. Okay, how do we determine our y? So you look at, if you fix one x, how the y changes. Okay, so if you fix x equals to -2, there's only one y here. And then when you move along, the y will increase. But when x equals to -1, the lower bound of y changes. How it changes? Changes by the smaller circle. 对吗？被小的那个 circle bound 住了下面。And then you move again. And then it is bounded below by y equals 0. Okay, so how do we split this out? So we should split our s into 3 parts. 2 parts or 3 parts? 3 parts. I think 2 part is using the same y bound. Fair enough. So let's do it. So let's do it. Let's do what I'm trying to say. So let's split into these 3 half here. So let's draw it. So one part we go from -1, -2 to -1. The other one we go to -1 to 1. And then the last one we go from 1 to 2. So from -2 to -1, what's the lower bound here? Y equals to 0. What's the upper bound here? Square root 4 minus x squared. Correct or not? So you have this part and then this part. Okay, like this. And then the second part, the lower bound is what? Square root 1 minus x squared. And then upper part is, again, square root 4 minus x squared. And then the last part is the same as the first part. Okay, just that you change your y. Change your x. So throughout these three integration domain, right? Can you see that all the upper bound is the same? Can you see all the upper bound of y is the same? 全部都是被那个大的。在图片也是这样。Okay, in the picture is also the same. 对吗？最高的那个 y 就是最大的那个circle。But the lower bound is different. 因为 the lower bound on -2 to 1 and 1 to 2 for x is bounded by horizontal line. Okay, so 这两个 part 都是 y 等于 Only the middle one is bounded by the smaller circles. Okay 吗？看得懂吗？ Okay, so well, I mean, if you're gonna do this integral, can you imagine what happened inside your integration, integrand? Can you imagine what happened? You need to integrate over a square root function. You can go back and try. I mean, did I try? I think I did try it. I don't know. I think it's I try one. Yeah, you can go back and try that. You can do this. You can change direction also, dy dx. Okay, but to save this hassle, sorry, what? 什么意思？ You know. 在哪里？这个人啊？ Okay. Okay, later we'll see this. Okay, later we'll see this. Okay, right. So if you do rectangular coordinate, you will need to like integrate all these square root thingy. But now we're trying to use polar coordinate because why? Because this part is like a pizza, right? Pizza slice. Okay, so we can try to make a change of variable. Okay, to describe this polar rectangular actually. Let's see how we describe this domain using different way. Okay, so let's try it. So let's remove all these dy dx. That's kind of problematic. Okay, so let's see. Right, so I claim that this region here, I can write it using the polar coordinate. Okay, can you imagine what kind of polar coordinate I can use? Can you try and fix my r first? Can you fix my r? My r is ranging from where to where? Radius going from where to where? 苍蝇。1 to 2, good. 很好 1 to 2. How about angle 呢？是不是 nice circle? Right, because we give you a circle of equation. So this angle going from where to where? From 0 to pi. Okay, good. Because our angle start from positive axis. Okay, so this will describe this R already. But since you make your domain into polar coordinate, right? You should also make your function into polar coordinate. So in this case here, what to do? You just simply substitute the polar substitution. So what's the polar substitution here? 3 times r cos theta plus 4 times r sine theta square. But remember, I told you that if you do this change, you need to multiply by an extra r. Okay. So do you want to do dr d theta or d theta dr? I think in this case, it's not too much difference. So let's do dr d theta. Why is it not much difference here? Can you see here that there's no dependent of each other? So it's like a normal rectangle. Okay, it's like a normal rectangle. Fubini's theorem. You can use Fubini's again. Okay, so let's do dr d theta. Okay, so you can compute this. You want to try and compute? What do you get? Yeah. Oh, sorry. Thank you. So I'll try and compute what you get. You need one trigo identity here. Let's see. What's the trigo identity you need? You need a sine square theta equal something. Equal 1 minus cos 2 theta over 2. I probably need this to help you. Yeah, you should notice that this function in r and theta can separate, right? So you can do the two integration at the same time. You know what I mean? You know what I mean? Huh? So let me write down what I want to say. So, because your double integral is linear, so you can split out the sum. On the other side, a bit troublesome. Huh? Is it troublesome? Not really. So just split it. Yeah, you can do all the integral at the same time, actually. Yeah, you can do all of them at the same time because you can split your product of function into separate variable. What do you get? 有人算完了吗？ 15 pi over 2. Okay, good. It's 15 pi over 2. 看到啊? Okay, good. Yeah, actually, you can do all of them together, actually. Okay? Yeah, it's 15 pi over 2. If you cannot compute, please check your integral. Right, so I mean, you see, I show you these cos theta, and then I show you there's a computation of square root. You still also get the same answer. Did you relate back what you learned in high school? Try to relate integration of some square root function to some theta. 有印象吗？会算出 tangent theta 的 integral。有吗？有印象吗？有吗？有印象吗？ Set theta equals to 什么 1 over square root x square 加 y square 之类的。有吗？有印象吗？谁有印象啊？恩慈哈，还谁点头？你点头，说说看，什么印象？有印象吗？其他的？我是说马来西亚人啊，中国人我不知道，但是马来西亚人 at least 应该有学过这个，还是需要他再讲一次？先让他讲过吗？再讲一次，再慢慢讲。
let x 等于 sin 或是 sin，然后就用那个三角的 identity。
有吗？ 你在做什么？其实你就是在做 polar coordinate，没有啊，你就是在做 polar coordinate 啊。Sorry. Oh, calculus also you got do, is it? Yeah. Yeah, calculus also got. So 中国人也跑不掉了。对，你也看过啊。So what you actually doing is a polar coordinate, changing from rectangular coordinate to polar coordinate. 算比较简单啊，不然你就要做这么多东西。其实在这边做东西应该也有用 Q 吧？忘记了，好像没有。Anyway，看看另外一个 direction 呢，好像也没有。But anyway， okay, right. Let's look at the other one. Okay, let's look at the next one. So similar here. Okay, if you want to find the volume of solid bounded by z equals 0 and paraboloid 1 minus x squared minus 1 squared, meaning what? If you look at this picture here, you want to find the area under this paraboloid. Okay, but if you look at here, what's this domain here? Can you identify this domain or not? Can you identify this domain? How to find this domain? How to find this domain? Can you identify the domain you want to integrate over? What's this domain here? S squared plus y squared equals 1. What's this? This is just a circle, right? But the domain include everything inside. So meaning what? You want to take all the xy in R2 such that x squared plus y squared is less than or equal to 1. You need to take everything inside the circle also. Because we don't just want this circle, we want everything inside. Okay, but this is a circle. Circle is a kind of polar rectangle. Is it a kind of polar rectangle? Can you write it as a r theta form or not? What is the radius you take? What is the angle you take? Radius going from where to where? If you want a circle. 0 to 1 in this case. Angle 0 to 2 pi. Okay, no. So, well, I mean, what's your z in this case? I mean, what's your fxy in this case? How to get this height function here? You let your fxy equals to z. Okay, so how to find this volume? This is a double integral on z dA on d. I mean, yeah. So, how do you do it? This is a very simple polar rectangle. You can do whatever direction you like. So I put like this. Correct or not? If I put like this, can I start do integration now? Can or not? Can I write like this? Does this make sense? Huh? Why not make sense? Okay, we need to change x, y to r and theta because we integrate over r and theta. So you need to tell me how x and y depend on r and theta, but how to change? Change. What's the substitution you do? So you just take 1 minus r squared. Why? Because you know that r squared equals to x squared plus y squared. Or if you don't want to do this, you just do the usual one, this one, universal. R equals to r cos theta, y equals to r sine theta. But if you square them and then add them up, you can factorize the r square and then use the trigo identity. Sine squared theta plus cos squared theta equals to 1. Okay, no? Okay? Yeah, so I think we won't compute this. You can go back and compute. But can you do it on dx dy or not? Let me ask you a question. Do you know how to do it on dx dy if we're going to do it using dx dy? How are we going to do it? Can you do it on dx dy? How? So let's draw the domain out. So this is an x squared plus y squared equals to 1, right? This circle here. But how do you do it on dx dy? So let's say dx dy. So y ranging from where to where? -1 to 1, correct or not? Because the radius is 1, center at 0. So here -1, here 1. But how about x? How x changes? Minus square root 1 minus y squared to square root 1 minus square. Okay, yeah. You can do it. Go back and do it. I got previous year student do it. Okay. Yeah. So you still compute to the same answer. Okay, both of them compute to power 2. Okay. You can try and do it. So this guy did dy dx. So maybe you can try dx dy. Okay, after you try, you can send to me. Yeah, you can try dx dy. Okay, so next part. Okay, so next part we come to this guy. Okay, so do you know how to compute the integral of the first one? What can you use to compute the integral of the first integrand here? Use the integration by substitution, right? Substitution, okay. But the second one, can you substitute or not? Cannot. Okay, cannot. So we're gonna use some advanced tool we learn now to compute it. Have you seen this in your statistic yet? 哎，是叫 statistic 吗？你们就是学的 probability. Did you learn this integrand? Haven't me? I thought they mean say gonna teach before. 跟你讲答案对不对 Yeah. Okay, so we're gonna learn how to compute this now. Okay, so actually this one is not in our notes, if you notice. It's not in the lecture notes. But it's when the first time I taught this course, Tao Shen, another lecturer, Tao Shen, is teaching probability. So he requests the student to ask me to prove this. So that's why I included in this syllabus now. Okay, so we're gonna learn this. It's not in your lecture now because this is requested by that time lecturers. So well, okay, let's do it. How to compute this? So we're gonna, so you see, I put this behind polar coordinate, right? So it hints that we're gonna use polar coordinate stuff to compute it. Right. So the claim is, what's the claim? Claim is the integral from negative infinity to infinity of e to the minus x squared dx. So we won't compute the general form. We will compute the one for negative infinity to infinity. So we sum everything out. Correct or not? In principle, if you sum everything out, is what? Should be infinite, right? But in this case, it's finite. Okay? In principle, 如果你把无限个东西加起来，不是应该要去无限吗？ But in this case, it's finite. And square root pi, pi 跑出来哦 ，pi 跟什么有关系？圆圈啊。Okay, so we're gonna use the polar coordinate here. Okay, so what to do? So let's assume it converge first. Okay, let's assume it converge. A bit like Ramanujan summation, but anyway. So e to the minus x squared dx. Assume this is a number. And then consider the square of it. We don't know how to compute one thing. We make it more complicated. Turns out that you can compute the complicated one. This is one way to do maths. This philosophy is promoted by a mathematician called Grothendieck. Maybe people are doing it, but Grothendieck say it like this. So you have a nut. 数学题嘛，很难嘛，你就把它想成一个很坚硬的核，你破不了 ，you cannot break the nut。通常我们 break the nut，what do you use 啊？很尖的东西嘛，很利的东西，一个刀 to break it。假设你不能 break 它，怎么办？我们拿水去淹它。We take a lot of water or anything to cover it. Okay, cover until 它的外壳变软 ，until soften the nut, such that you can break it through easy. OK，这就是一个方法做数学，就是你拿一个很大的东西去算，你找嘛，哎，反而找得到。OK， yeah. Okay, so this case is what we want to do now. So let's consider I squared. So what is I squared here? I mean, you just take two integral and multiply them together. Well, I mean, if you take a product, you can use different variable because in principle they are not related. Okay. but what's the trick here? So the trick here is use Fubini's, but I mean, I don't want to say that, but we try to combine these two functions together. Okay. It's like how we split function just now. Then what is this? If you're going to change a variable, what is this? If you put two variables multiplied together, actually you get a plane. But in plane, you can describe it using r and theta also. If you describe plane using r and theta, what's the variable you should use? So you have dr d theta. Obviously, you need to multiply by r. But what's the radius here in this case? 0 to infinity. But your theta is finite. I don't know. Just 0 to 2 pi is enough to cover everything. Similarly, you need to change your variable in your function. It will become minus e to the minus r squared. Hey, what is this? Integrate e to the minus r squared r. You go from the sad face to the laughing face again. 跑回来哦。You go from the sad face to the laughing face again. Hey, I know how to compute this. Correct no? So how to compute that? We can use integration of by substitution. So let's see. So how to do it? So well, I mean, we really can split the two integrand again because one of them depend on theta, the other one depend on r. So you integrate to infinity, right? So what you really need to do is an improper integral here. Let's call it. Okay, so on one side you get what? 2 pi. On the other side, after you do integration of by substitution, what do you get? Negative. Huh? Z. Oh, minus r squared, right? And then going from 0 to 还有一个 1/2 有吗？哈，有吗？有 1/2 吗？有，好像有。1/2把它拉出来，放里面，放里面这样拉出来，放里面。OK，and then integrate from 0 to a， 可以吗？大家算得到吗 ？Integration by substitution。OK，but what is this 啊？2 pi 乘 1/2. Okay, so we get pi. So what do we get? I square equals to pi implies I equals to 0 pi. Is that okay? Okay. All right. 几点了？11点40。Any question about this one? Yeah, 来分上。Yes, yes, yes.
Not like
It is a coordinate. Just that these S and Y shouldn't have any relation to each other. You can use Z also. Yeah, yeah. Mhm. Okay, so X is one direction. Sorry, yeah, X is one direction, Y is the other direction.
it's not necessary to be horizontal.
You mean perpendicular? I mean, what? Well, I mean,
Just create
mhm,
and Y.
yeah, correct.
Y is
Correct.
something that you create.
So I mean, if you put X and Y together, right? What do you get? You really get the whole R2, right? Because all the possibility of R. So this is what it means. You get what I mean? So you have R. Okay, on X you have a whole R, and then on Y you also have whole R. So if you put X and Y together, shouldn't you get everything inside R2? Yeah. So this is what it means. I didn't imply that these two directions is perpendicular. Just that if you put them together, you will get everything inside R2.
Why you use X square, also X square equals to R square.
Wait, let me think. Let me think. Oh, this is your concern, is it? I mean, if you are worried about that, maybe, I mean,
y 就是等于minus x minus y 对，
uh-huh.
再推出那个上面的那个。
哦，我觉得这样推也比较好，这样推应该比较好，because it's continuous。Yeah，我觉得那样推会比较好。But 你的那个应该不会太大问题，because actually, when we do that, we assume that they are independent because we already create a double for them. So X I put in the first spot, Y I put in the second spot. Actually, try of hinting they are linearly independent. Yeah, I think 他讲的比较好，我觉得。Actually, we should start. Actually, we should start here. Actually, we should start here. Why we start here? Because if we start here, this is a continuous function. A continuous function on the rectangular. I mean, but this one is infinite, and we don't have we don't have theorem to talk about this. But I mean, there's some gap actually. Maybe you can try and fill in the gap. And there's a gap here. Because whenever we split, we do integrated rectangle, right? For us, the rectangle should be finite. But in this case, it's infinite. So there's still gap there. Yeah. I mean, there's a kind of sleep proof. You can try and fill in the gap. But you can use this for now. In this course setting, you can use it. 怎样？什么？ Sure, yeah. Maybe you need to use improper integral to send the result for Fubini's. Yeah. So what's this? Well, actually, how many limit you need? 4 limits you need about this one. You need to take this to negative infinity, this one to infinity, this one to infinity. So you need 4 limits if you want to use the Fubini. So Fubini's is 4 finite number, right? And then now you need to take the 4 finite number to it. Maybe you can try and figure out. Maybe you can try. But for now, we are not worried about it. You can use like this way. Okay. Any question? Any other question? Hey, 问题吗？You know how this what's the shape of this surface or not? E to the minus x squared minus y squared. 如果我没有记错啊 maybe you can use the cow plot. I think it's a plane and then with a bulge in the middle here. Okay, so it kind of a decrease fast. Okay, when you go away from 0, decrease fast when you go away from 0. Okay. So where your square root pi come from? Mostly it's come from the middle dome there. Mostly. Okay, it decrease fast. Fast until the whole integral is finite. Hey, by the way, I saw something in your test. You use decrease fast to compute limit. Is that allowed in calculus one? Want to ask? Huh? So there's a limit for quotient, right? Limit for numerator and denominator. So you said that the denominator is decreasing faster or increasing faster than numerator. Huh? Sorry? Discrete math? Hit that? Why? Complex number, I mean. 什么是 complexity? Oh, big O notation. And then? 有没？可是 do you use that to compute actual limit or not? 觉得好像那个东西是不该在数学系里面看到的东西。如果哪一个老师允许我要抓那个老师，我有证据，你们的考卷我都在，我可以找那个学生出来。你 project 没有这样写啊？是你的考卷，你的考卷。所以之前有没有老师抓到你啊？还是怎样？可是什么老师允许你写那个东西？我没有写过。OK，yeah，啊，不止你一个，其实，所以我要问，还有几个也是这样写这种东西的？应该不可以出现的这个东西，那个是大忌来的，不可以用这种 argument，因为有时候你要 verify， 你一定要 verify 为什么下面跑快过上面，这样看起来差不多，一定要 verify 一定要 prove。可能开会的时候要提醒一下这老师。I think it's a good time. Let's stop here. We'll continue later. Where's the later venue? A4G06. Okay, see you later.
已上课。